Well, welcome to this tutorial on caustics. Before we get into caustics, a very quick refresher on the phenomenon that causes caustics, which is of course refraction. And refraction is what happens when light passes through a dense, transparent object. And what happens is that it gets bent. And we can see this quite clearly from this photo. The straw appears to be broken because the light coming through the water and the glass is being bent. The amount the light is bent depends on something called the index of refraction. And you can look up indices of refraction quite easily on the internet, and there are lists of them for various common materials. Air has an index of refraction of about 1, and glass, some types of glass, have an index of refraction of about 1.5. The amount the light gets bent depends on the index of refraction outside the object as well as the index of refraction inside the object. Now, quite often you don't need to worry about the index of refraction outside the object because your object is sitting in the air, and air has an index of refraction of 1. But if, as we will see later, we're talking about a situation where you have some liquid in a glass, for example, you need to start thinking about this issue of the inside and outside indices of refraction. How do you tell what is outside and what is inside? Well, in a 3D application like Houdini, where you're dealing just with thin surfaces, the answer is to do with the normal. The normal of the surface points towards the outside, and the other side of the surface represent the inside. And we'll see that later on. So I've modelled a NURBS glass here. I've used NURBS, but equally you could use polygons, although it's quite important to ensure that your object is modelled using smooth surfaces, so either quite a high polygon count or using NURBS, which are automatically smooth. That is, of course, if the object that you're modelling is intended to be smooth, which in this case, of course, it is. So the first thing to check is whether the normals of our surface are set up correctly, because that's important for the appearance of the object later on. And we can display normals using this button here, and let's go into wireframe mode, but it's often quite tricky for NURB surfaces to see the normals because Houdini only produces a single normal for each surface, and that's the normal down there. And one way to visualize them, therefore, is to lay down a convert node, like so, and convert the surface temporarily into polygons. And if we do that, let's change it to shaded mode, we can see that in fact our normals are all pointing inside and not outside. So we're going to need to add a reverse, which will reverse our normals. And now we can see that they are pointing in the correct direction. And at that point I can disable the convert so that we just have an surface. The next thing I'm going to do is lay down a grid and enlarge it. And then I'm going to put some texture coordinates onto the grid, which I can do using UV project. And I'm just going to use the standard orthographic projection. And now I want to add some materials to our scene. And I'm going to need a glass material. Which is here somewhere. And I'm going to use a checkered material. Like so. Let's change the colours of the checker material to something slightly more attractive. And let's put our checker material onto the floor and our glass material onto the cup. Now I want to set up a light, so I'm going to use a spotlight. So I position the view where I want to see it as it would be looking through the spotlight, and then I control click the spotlight to create the spotlight. And then I'm going to lock the camera and zoom our spotlight in a bit, like so. And I'm going to enable ray trace shadows on our spotlight. And the next thing we need to do is set up a camera. And then I'm going to create a render node. And let's go into our render view and render the scene. And at the moment I'm just using the standard Mantra renderer. I'm not using PBR. They will come on to that. And we can see that we get a nice render of our glass, and that looks reasonably like a glass. And then we're getting this complex effect in the shadows. We've got a lighter shadow in the middle and a darker shadow on the outside. And the reason we're getting this is because our glass shader comes with something called false caustics. And we can find that in our lighting effects tab under the caustics tab here, and you can see we've got do false caustics or faux caustics enabled, and that's what's producing this complicated shadow. And in some cases that's what you would want, and because calculating real caustics is quite expensive, it's sometimes fine to use something like this, perhaps a slightly blurred version of this, to create a caustic effect without spending the time to create a photon map and so on. I'm going to turn this off, and then let's re-render. The other thing we notice immediately is that the shadows from our glass are very dark. They don't seem to represent an accurate shadow for light travelling through a transparent material. And that's right, because our glass material does not calculate the shadow based on the amount of glass travelled through. It just produces a solid shadow. But we can adjust that shadow using the shadow colour. And almost always for a glass material you're going to want to up this quite considerably to say 0.9 or 0.8 to produce a much lighter shadow. That looks a bit more like it. Now we can see that we still have a couple of issues with this render, one of which is that there's this black spot in the centre of the bottom of the glass, and also we're getting these very black parts of the glass at the top and the bottom. Let's try and address the black spot first. And this kind of effect is often caused by the fact that your transparent surface is overlapping slightly with another surface. Let's have a look at our scene view. And here I've got it in the orthogonal view. And although you can't see it, it's possible that those two surfaces are so close together that we're creating that effect. So I'm going to move the glass up just a little tiny bit. Not so much that you would notice in the render, but hopefully that will eliminate that black spot. And indeed it has. The next thing to address are the black areas inside the glass here. Now I'm going to switch to the PBR rendering engine because the way to correct this differs between PBR and normal rendering. In normal rendering you can simply use the glass shaders parameter here where you can set a background color. So if I set a background color like so, we can see that the dark areas that we had earlier become the same color as the background color. And that's because the dark areas are simply the reflections of the environment, and earlier we had an environment that was black, so we were getting black reflections. However, if I move to my output network and select our render node and change the render type to physically based rendering, we can see that the black areas return. And the reason they return is because PBR does not recognize the background color parameter of the glass shader. So we need to find another way to eliminate those black areas. And what we can do is lay down an environment light. So I'm just going to return to our scene view. Let's hit space and 1 to get back to the perspective view. I'm going to turn off the display of normals. And I can just control click on an environment light to add it to the scene. And I'm going to take it and I'm going to give it a light blue color, I think. And we'll make its intensity quite low. 0.3. And let's have a look and see what that looks like when we render. Well, we can see that for the most part it's eliminating those black areas. We're now getting reflections of the environment light.